I apologize for the issue that must have happened when I was recording this section 3.5 rational function video, and it was supposed to go to, I think, question number 9, and it cut off prematurely. So I'm going to go ahead and do a little short video on 8 and 9. Alright, we are still finding vertical asymptotes and or holes in the graph of the function. It is a rational function. I'm going to take a minute to just identify the domain exclusions. Alright, I take the denominator, x squared plus 21, set it equal to 0. When I solve this equation, I will find the values that x cannot equal. They are not in the domain. Now if you just try to factor this, you'd say, well, 21's not a perfect square, but the main thing is this is a sum. The sum of, if it had been a square, is always prime. Maybe you went away from factoring and said, well, I'm going to try the square root property. X squared is negative 21. Take the square root of both sides, doing plus or minus the square root of negative 21, and this is going to give you imaginaries. When those solutions are imaginary, then what you find out is that there are no real exclusions. And when we talk about exclusions, we are always limiting ourselves to the real numbers. There are no exclusions. Since there are no exclusions whatsoever, the domain is from negative infinity to positive infinity. It's all real numbers. That's the domain. But the question was, are there any vertical asymptotes? No, they would be indicated as certain kinds of domain exclusions. So there are no vertical asymptotes. Are there vertical asymptotes and holes? No, there are neither. Are there just holes? No. My correct response is there are no discontinuities, and a discontinuity is a break in the graph. Since there are no domain exclusions, there are no breaks in the graph. That is the answer to question number 8. Let's look at 9. It's the other one that got deleted from the first video. Alright, the first thing I want to do is just look at domain exclusions. Now this is what you did in questions 1 through 4, I believe, and that's all you did on those. So we take the denominator, x minus 12, set it equal to 0. We find x equals 12 is a domain exclusion, and the domain, although that is not the question, the domain is the set of all x's such that x is not equal to 12. That's not my question, but when we are looking to then classify these domain exclusions as either vertical asymptotes or holes, I need to factor and reduce, possibly, f of x. Now f of x starts out being x squared minus 144 all over x minus 12. The numerator is the difference of squares and factors into x plus 12 times x minus 12. The denominator does not factor, it is the factor x minus 12. Now the only domain exclusion that I get is from this factor x minus 12. And yet, when I try to reduce it, that factor divides out, and this is equal to x plus 12. The factor x minus 12 is what led us to the domain exclusion of x equals 12, and because it divided out and is no longer part of it, says that this is a whole. If it remains, then it is a vertical asymptote. So it is not choice A, it is not choice B, because those both refer to asymptotes. Choice C says there are no vertical asymptotes, but there is a hole at x equals 12. So vertical asymptotes exist for factors that stay in the denominator, resulting in domain exclusions. Holes exist when you have domain exclusions that divide out. All right, so that's 8 and 9, and then you can go on to the next video.